notes? We're going to start with a right triangle. We already know what kind of triangle it is. And you always start with a diagram. Step one is a diagram, but more than that, you also have to label it. So, step one, start with a labeled diagram. You need to draw this. Go. Give yourself some room. Start on a new page. The people who got this right, everyone who gets this right on tests and things, usually uses a page to do problems. When you're doing word problems or you're doing very difficult problems, you should use an entire page and make it clean and clear and neat. You should label your diagram. What side should I call this? Smallest side. I usually call the smallest side A, and of course that's across from vertex A. What about this side right here? B. The legs are always A and B, and it's across from vertex B. The right angle, I always call it C, and it points at the hypotenuse, which is C. After you have it labeled, what's next? After you have a diagram and it's labeled, you write your formula. Of course, you better know the formula by now. What is it? A squared plus B squared equals C squared. We know it's equal because we know it's a right triangle, right? We start out knowing it's a right triangle, so we know this is true. A squared plus B squared has to be equal to C squared. We're going the other way. Did everybody see what I mean? Before, we checked this to see if it's a right triangle. Now we know it's a right triangle, so we're going to use this to find the side that goes with it. What do you do after you write a formula? Substitute inside parentheses. Always substitute inside parentheses. I hope you all notice I'm doing the same thing every time here. There isn't any change, ever. Math works out the way it works out, and it always stays the same. What goes in here for A? 5. What about B? And C, we don't know. You could call it X, but it's just as easy to call it C. Now this is 25 plus 144, and it's equal to C squared. What are we doing right now? When we square these and add them together, what step is next? Simplify. You always want to simplify it as far as you can before you try and solve anything. Always get everything together. Now we can add those together. That is 169 equals C squared. The last step, step 5, solve. And we can solve this by doing the opposite to both sides. The opposite of squaring is taking the square root. And the nice thing is that it works out exact, doesn't it? What is it? 13. It works out very nice. Let's make it feet. Sorry, I should have given you some units there. In fact, this is exactly 13 feet. This is called a Pythagorean triple because it works out really nice. 5, 12, 13. This is one of your Pythagorean triples. 3, 4, 5 is your most famous one. There's also some more. 8, 15, 17. That's another Pythagorean triple. All of these work out really nice and give you right triangles. They're called Pythagorean triples. Now, sometimes they don't work out really nice like this. Let's do example B. This one does not work out so well. let's go with new triangle, everybody. Don't wait for me. Label your diagram, then write your formula, then substitute, then simplify, then solve. Go through all your steps. This is C. This is B. The points here are C, and this, of course, is A, and this is B. C is always across from the hypotenuse. Write your formula, substitute, simplify, and solve. Don't use your calculator if you can help it. If you happen to remember 16. If you don't remember it, that's okay. You can use your calculator a little bit. Now when we go to solve, you have to subtract 256 from both sides. Did y'all do that? When you get to the solving step, you have to subtract 256 from both sides. And a squared equals 144. Then what? Square root. What is a? Let's make these centimeters. What is it? 12 centimeters. Again, this one is a Pythagorean triple. It's a form of 3, 4, 5. Let me show you how. 3, 4, 5 is the most famous Pythagorean triple. Notice what happens if I multiply all of these by 4. I get 12, 16, and 20. This is another Pythagorean triple. You can make lots of them by multiplying by any number you want. You can multiply 3, 4, and 5 by any number. Just like you can multiply 5, 12, and 13, 8, 15, and 17. Because they're all going to be similar, aren't they? Remember when you multiply all the sides by a given ratio? You end up with the same triangle, which is going to be a right triangle. Now for the inter